science already? Most of you? How many of you taking grade 10 science right now? Okay, so what we're looking at is when we do measurement, there's two systems of measurement generally in the world. There's the metric system and there's the imperial system. The Americans are basically the only ones that use the imperial system. All right? But when it comes to science and math, everybody uses the same system. It's called System International. So they talk about it in terms of SI units. Okay? So in physics or grade 10 science, all right, the standard units for time is seconds. So what this means is that primarily, if I was talking about how fast you're going, you have 100 kilometers an hour is what we generally talk about in terms of our speeds in Canada. In the States, it might be 60 miles an hour. But in physics, we're going to talk about it in terms of meters per second. Okay? Because the standard in the SI units in time would be seconds. Distance, I just alluded to it, is meters. So that way or the other, whatever. Okay. And what's the other one? Just a second. Length. Time. And mass. And mass is kilograms. So when we talk about, for example, I say, okay, what's the speed limit in Canada? Generally on a highway, what's the speed limit? It's 100 kilometers an hour, unless you're on TransCanada, it's 110 kilometers an hour. But we talk about in terms of kilometers an hour, right? So in physics, if I'm doing a question, I'm going to convert that 100 kilometers an hour to meters per second. Now, if I'm talking about the speed of light, though, it's a large, large number. So sometimes I'm going to change it from meters to kilometers, all right? Or I might change it from seconds to hours, depending on what it is I'm measuring. Okay, so that's the first thing that we're going to do in this first section, is work on doing our conversions. Okay, you don't have to memorize them right away, but you have to be able to convert from one unit of measurement to another unit of measurement. So for example, if I asked you to convert 143 meters into centimeters, let's say. Does anybody know how you would convert 143 meters into centimeters, Jake? Times by 100. How come? All right, excellent. Okay, so Jake knows what the conversion is. So the way I teach this in physics is I say, okay, what is the unit I want? I want centimeters. So what's the ratio of centimeters to meters? If I know it, I'm just going to use it. So what is the ratio? Jake says 100 centimeters to 1 meter. So therefore, my units cancel my meters because I have meters on top and I'm dividing by meters on the bottom. So just like if I were to have numbers, when you have a number over another number, they can cancel out if they're on the top and the bottom of a fraction, right? 2/4 can be 1/2 because the top and the bottom can divide by 2. So I can do that with units. So what unit am I left with? Centimeters. And then I punch it into my calculator, and I have that. Okay? So what about if I had 208 millimeters, and I want to convert it into meters? How do I convert that into meters? Go ahead.
You times by 10 then by 100.
Times it by 10, and then by 100?
Or 1,000. So times by 1,000.
Okay, so what are you using as my ratio? So, are you trying to go directly to meters?
Yeah.
Okay, so then what I want to do is I'm going to put millimeters on the bottom, because that's the one I want to get rid of, right? And I want to convert it to meters on top. Do you know the ratio of meters to millimeters? Do you know how many millimeters there are in a meter? 1,000? 1,000 meters in 1 millimeter?
No, 1 meter and 1,000 millimeters.
Right. So you have 1 meter in 1,000 millimeters. Okay? Now, if I didn't know that, what could I do different? Well, I could change millimeters to centimeters first, right? And then I could change centimeters to meters. That would be an easy way because they're both by tens, correct? Well, one's by 100, I should say, they're both by tens. So now what? Okay, so I just finished saying if it's on top, I have to divide by the bottom. So do I actually multiply it by 1,000? No, I divide it by 1,000. So I take 208 millimeters and I divide it by 1,000, and that's how many meters I'm going to have. So I'm going to have 0.208 meters. Now, one way I'm going from smaller to bigger, and the other way I'm going from bigger to smaller, but the process in which I use stays the same. I never change this process. I'm going to show you one. You don't have to write this one down, but here's an example of why I do this. Okay, I said the standard SI units for speed or velocity is meters per second, but this is in kilometers per hour. So I want to change my kilometers per hour to meters per second. So I have to use a couple ratios, because the first thing I want to do then is I want to change kilometers to meters. So how do I change kilometers to meters? Well, what do I want? I want meters. What do I want to get rid of? Kilometers. So it has to be on the opposite side of the fraction as the units that I want to get rid of. That way, that cancels with that, right? What's the ratio of meters to kilometers?
1,000 meters in 1 kilometer.
1,000 meters in 1 kilometer. Okay? So now I've got meters, but now what do I have to change? Remember, I want my,
Hours to seconds.
what do you got?
Hours to seconds.
Hours to seconds. Do we know the ratio of hours to seconds?
360 seconds in an hour.
Well,
I meant 3,000.
3,600, that's right. Okay, there's 60 seconds in 1 minute, right? And then there's 60 minutes in 1 hour. So if I multiply those two numbers together, what do I get? 3,600. So the ratio is, and again, you don't have to go right to it. I'm doing it to shortcut it, but I could change it to second or to minutes and then to seconds. But what is it? 1 hour, 3,600 seconds. So now what? I multiply across the top and I divide by the bottom. So I take 100 times 1,000 and I divide it by 3,600. Okay? Calculators out. If you have one, take it out right now. What do we get? 100 times 1,000 divided by 3,600.
27.78. Well, it's like
Good.
77.
Yeah, that's all right. I like that you went to 2 decimal places. And what are my units?
Meters per second.
Meters per second. Because the meters and seconds is what I wanted to get. Okay? But again, the procedure, the way in which I do this, it doesn't change. Doesn't change whether I'm changing from one to another or I've got multiple units to change. I just always make my ratios show up. The stacking method makes it a lot simpler for me to do this. Okay? You're given on that very first page, actually flip back, it's about 3 or 4 pages to page 9 in the Roman numerals 9. So just keep flipping back to Roman numeral 9. Everybody knows what 9 is in Roman numerals? IX.
You both have it. So, wait, yeah.
Okay? So what you have there is what you can use as you go through this section, and that's the conversions. So you've got 10 millimeters in a centimeter, 100 centimeters in a meter, and so on. And then you've got your imperial, and then you have your SI to imperial and your imperial to SI. That means if I wanted to, for example, if I had 26 meters and I wanted to change it to yards, let's say. So what's the ratio? 26 meters So I want to get yards out of it.
Times it by 1.09.
Okay, just a second. Let's set it up to make sure that we've done this the right way. So I've got yards on top, meters on the bottom. Do we know the number of yards in a meter, or do we know the number of meters in a yard? Do we know both? Okay, there's both there, right? So let's do yards to meters then. So 1 yard has how many meters in it? 1 yard, 0.9144 meters. So now what do? What do I do now?
You times 0.6 1.9.
I multiply them.
Yeah, divide.
Multiply across the top, divide by whatever's on the bottom, right? Because this line means divide. Even in a fraction, that line means divide. So if it's on the bottom of that fraction, you have to divide by it. Okay, so I take 26 and I divide it by 0.9144, and what do I get? 39.37. Thank you. Yards. So there's 39.37 yards and 26 meters.
I didn't get that.
You didn't get that? Seems a little high.
I got 23.3.
Okay, so let's go back there again. What did you get? 28.43. Okay, you want to try it again? Okay, that's all right. So now, just thinking in my mind right now, just looking at it, it was, I think we had 36 or 38, whatever we had on the board there. But look at how close these guys are. They're not very far apart, right? There's 90, it's basically 90% of a yard is a meter. So they had to be pretty close together.
Are they multiplying when they do 26? I think they're multiplying.
Are they?
Yes, they are too.
I think they are too. Okay, so let's go back and do this again, because I also think that's not right. Now, let's just talk about it for a second. Okay, 1 yard has 0.9144 meters in it. When I look on this, I also see that 1 meter is 1.094 yards. So if I'm looking at it, I'm thinking, am I going to get a larger number than this or a smaller number than this when I do this question? I should get a larger one. Okay? Because there should be more yards than meters, right? Because there's 1.09 yards for every 1 meter. So now, take 26 and divide it by 0.9144. Is that what we get? What did we get there?
28.43.
And that was the right answer, was it not? That's what we had?
Yeah.
Right? That's you got the second time? Yeah. Perfect. Okay? Alright. Any questions? Everybody's okay with this conversion stuff so far? Okay? Again, those that are in science, you probably have done this a bit already, right?
Yeah.
Okay. The last thing, look on page 2, please. Those of you that were in science may or may not have used a caliper to read. I had you. Okay. So, has anybody in here read a caliper before? Did you do it in grade 9? No? Okay. So here's how this works. All right. The fixed scale is the scale at the top. So I'm looking at this guy right here. Okay. So I want you to look at it. So the first thing I do is I locate where that 0 is. And I want to find the big number first. So is it between 1 and 2, 2 and 3, or 3 and 4 where that 0 is located? It's between 2 and 3. So I'm looking at the big numbers first. So that means my first whole number is 2. So what I've done is I have measured whatever it is I'm measuring, and I've noticed that it's slightly larger than 2 centimeters. Okay? So now what I'm trying to do is I'm trying to find out how small I can actually measure it to. So the next step, after I have measured that, I look at the little ticks, and that's my tenths value. That's my tenths value. Okay? So which tick is it between? Is it between, where's that 0 located on the ticks value across the bottom of the ruler? Pardon me?
The second one, 0.2.
0.2?
2.2.
2.2. So it's 0.2 plus. Okay, does everybody follow this or not? Your hands up if you don't follow it. Be honest. Okay, so Cooper, this 0 right here,
Yes.
it falls between the 2 and the 3, right? And then I look at the little ticks, and where does it fall between?
0.
The 0 falls between, on the little ticks right here, between the 2 and the 3. So that means it's 2.2 something. And what is that something? So this is the catch that we have to find out now. What is that something? Well, it's 0.0, and then how do I find it? What I do is I look at the scale on the very bottom, and I find out which one of those lines matches up exactly with the line above it. So you see where it points at step 2 there on that graph? That line lines up exactly with the one above it, correct?
Yeah.
What is the value on that bottom scale? How many ticks is it?
3 to 3.
There it is. So what is that actual measurement? 2.23. Okay? And that's how you read the caliper scale. Anybody not follow? If you don't follow, put up your hand. Cooper, you're good now?
Yeah.
Anybody else? We're okay? All right. I'll do one more example with you, and then you're off and running on your own. Okay? 2 students in a biology class measure the length of an insect specimen. Kelly determines the length to be 8 millimeters. Caleb states that length is 0.008 meters. What referent could be used to estimate the length of the specimen? Okay, so what is it asking? What could you use to measure, what would be about that size? What's about 8 millimeters? Well, they use, and I'm just going to use theirs because it make it quick, the width of a fingernail is about 8 millimeters. Okay, depending on how big your hands are, I suppose. Okay, what unit of measurement of all possible units is the most appropriate measurement for this? Which is more appropriate? 8 millimeters or 0.008 meters? Why?
It's easier to know what it looks like.
Makes more sense to you, right? It's tough to kind of visualize what 0.008 meters is. Oh, my meter stick, there it is. Okay, so I have a meter stick here, a yardstick, I don't know which one it is. 100, so it's a meter stick. Okay, so looking at this and trying to find out where 0.008 is over here, doesn't make a lot of sense, does it? Okay, so if I was measuring the width of this room, using a meter stick would make more sense. Fair enough? Okay. And then it says, how do Kelly's and Caleb's measurements compare? Are they the exact same measurement?
Yeah.
Yeah, you think so? Well, let's check it and make sure. 8 millimeters times. I'm going to change that to meters to make sure. What's my ratio? 1,000 what, sorry?
1,000 millimeters to a meter.
Yeah. So what do I do with the numbers? Oops. What do I do with the numbers?
8 divided by 1,000.
8 divided by 1,000. And does that work out to that?
Yeah.
Perfect. So we have the same measurements. Okay? That's all there is. So you have right now, I do this every time.